After learning how to name simple amines, you incorporate it into your repertoire of all the carbon names we already know, and eventually we'll start naming things that are more complicated. So you might run into a biomolecule of sugar or something like that. And in biomolecules and larger, more complicated structures like that, there are often a lot of asymmetric carbons. And one thing that people notice over time is that there is an extreme deficit in naming asymmetric amines. You'll see some really long name for something. You'll see R this, R that, S this, but you won't see any for nitrogen. And in the beginning you'll ignore it, but after a while it will piss you off and you will look it up. You'll check and say you'll look at some structure and say, there should definitely be an asymmetric nitrogen there. How come it's not named? Is it just being ignored? Is it not important? And the answer to this is yes and no. It is being ignored and no, and it is important but not at the same time. So I'll explain to you why that is. So looking at an amine, so something like this, so after this pisses you off, you will actually draw it on a piece of paper and you'll look and see if this is asymmetric or not. So here's something that's very obviously asymmetric. There's the nitrogen is bonded to 1, 2, 3, 4 different things. If it was a carbon bonded to 4 different things, we would say this is a chirality center and therefore it should be named as R or S. And here it looks like you can do the same thing. And you can. You can number them 1, 2, 3, and then this one's the lowest priority, this last 4. Shouldn't I name this as R or S? And the answer is no, because there's something called a nitrogen inversion. This lone pair of electrons here can change places, can go up and down on this nitrogen. So like the way the bonds can turn and rotate and go and interconvert, this lone pair can interconvert like this. So here's a transition phase where it's changing from the top position to the bottom position. And when it goes from the top position to the bottom position, the location of all these things changes. So if you were to compare this molecule to this molecule and number them all and give them an R or an S, you'll notice that it changes. So here this is 1, 2, 3, 4. So if you were to turn this around, this would be an S. So this is facing the top and this is the back. This is the lowest priority. This would be S. So this would be counterclockwise. So this would be pointing up, this would be on the left, and this would be on the right, and this would be in the back. And if you look at this one, point this up, this would be on the right, this would be on the left, so this would be R. And these cannot be superimposed. See, look here, if you were to try to superimpose these, H, hydrogen, is in the position where this methyl group would be. So since they interconvert back and forth, you can't name them. So it's not really a matter of ignoring them for the sake of it. It's because they are a chirality center, but there's no way of naming it, because at sometimes it is an S, sometimes it is an R. And the only time you see named nitrogens generally are when there is not a lone pair, and this would be bonded to something else. Say, instead of this would be CH2, CH2, CH3. And the reason that this can be named as an R or S because this lone pair is no longer able to interconvert like that. Or if it were somehow attached to something really, really sturdy where it wasn't going to move for whatever reason, or the activation energy for this to occur would be too high. So if maybe these groups were really, really heavy, it would be hard for the interconversion to happen. But it's going to be very, very rare that you see one of these amines actually named R or S, because the situations are not going to be that many, unless it's not a lone pair, it's bonded to something else. But if it is an amine like this, like I said, unless it's bonded to something really, really rigid, or the groups are extremely, extremely heavy to where at normal temperatures, it's not going to interconvert. You're not going to see them named at all.